Good afternoon, City Council. It is no secret that there is a lot of toxins in our oceans and seas that cause harm on our aquatic life and organisms. Today, I'll be discussing one toxin in particular, and that is the toxin microcystin. The three objectives I'll be discussing in this video is to give you an overall summary of the problems caused by microcystin, what exactly is microcystin, a toxin, and how and why microcystin has made their way into the water and harming aquatic organisms. The main problem with microcystin is that the toxin does not just cause one problem, but many problems. The toxin creates a domino effect in the aquatic ecosystems that it is found in. Microcystin first pollutes the water, then infiltrates smaller animals such as fish and shellfish. Then, as the situation turns out, a lot of aquatic organisms' diets consist mostly of that shellfish and fish that have been contaminated. There has even been an increase of dead otters being found on the California coastline due to the growth of microcystin. Another reason why microcystin pollution is dangerous is due to the harm it can cause to another animal that is very crucial to our ecosystem that tends to eat shellfish and fish too, and that is us, humans. And as mentioned before, the toxin microcystin is not a singular level problem, it is a multi-level problem that requires a multi-level solution. The big question I had while researching the problems associated and caused by microcystin was, what exactly is microcystin and why is it so toxic and harming our environment? The toxin microcystin is one of the most widespread algal toxins. Microcystin is also a product of cyanobacteria, which is more commonly referred to as blue-green algae. The problem with microcystins is not that they exist, since they occur naturally, but the problem is that there is an observed abundance of the toxins microcystin in our water. The toxin causes an extreme harm to the liver of the organism it inhabits. One of the processes that microcystins can have a large devastating effect on is glycogenolysis, which is a metabolic process that happens mostly in the liver and serves to regulate the glucose being released in the bloodstream. Liver damage is also just the start of the problems that can happen due to microcystins. It is also proven to have the ability to cause cancer in humans. Another question I had while researching was how microcystin made its way to the Earth's water. While microcystin can naturally occur, there is an abnormal amount of growth that is leading to the deaths of many aquatic animals, such as the shellfish, fish, and then the otters and seabirds that consume them. One large contributor to the increasing growth of microcystin is us, humans. Runoff human sewage and fertilizers used by farmers and gardeners can act as catalysts for the growth of microcystins, which only add to the already naturally occurring microcystins that are already in our waters. Overall, the case of microcystin is an interesting and an extremely challenging one, but with the help of conservationists, farmers, students, teachers, and everyone in between, we can come together as one and not only learn how to mitigate the toxin, but hopefully create long-term solutions that will help create a long-term decrease of the pollution of microcystin in our waters. And I want to thank all of you for listening to my video, and I hope you were able to learn something from my presentation. I will also have two fact sheets that go along with this presentation that you can take a look at and grab more information and resources both on microcystins and the process of glycocalysis. Thank you.